Hello everyone again. Today we continue our Petroceltic technical skill development, and in this video I will quickly show you the software which you will need to solve problem number 5 in your homework. So let's go to it. First of all, you need to go to www.pengtools.com, and if you don't have an account, you need to sign up and fill this form and sign up. So as far as I have an account, I will just log in. So this website provides petroleum engineers basic tools to do petroleum engineering online. For your task, you will need two models, PVT and PQplot. So for PVT, let's open it. And so by default, let me just expand it to a full screen. By default, I have Bulgaria dry gas model. So here we will create our PCI training model, and the date will be (13/12/2016), and we will share this model to a public cloud so you can use it, and it will be the gas model, so the units will be filled. And the properties will be as follows. We will use 50 for a specific gravity of oil, 0.722 for specific gravity of gas, one here. For the reservoir pressure, we will take this number, and for the temperature, this number. So with all input you need to initialize your PVT model for the gas. All graphs here, outputs are here, and table is here. So I'm saving this model and I'm creating a new one. And now this model is available for public. So how you can access it? You go to the PVT model, you click pengtools Cloud, you click Shared Models, and here it is, just created by me, and you can just click on it and it will open. So now when we have our basic PVT model for our training, we can go to a PQplot. So PQplot is a basic instrument to do nodal analysis. Here I will show you the basic functionality of this model so you can use it in your homework. I already prepared PCI training demo model here, and it's valid for today, and I will share it as well. The units will be filled as well. The model type is gas. So now next step is we need to do PVT input. For PVT input I used dry gas, but right now I can use my model which I just created. It's here, so I select it, and now PCI training PVT model is used. Basically, I will show you the Kearney's 11 well. It will be good for you, so you can apply this to the other wells. So for the tubing, we'll just start to input data. Tubing is tubing diameter inside and outside. We have casing, 7-inch casing, and we have perforation depth is 9186. All these parameters are coming from basic wellbore design. So for the deviation survey I already have it loaded, but this comes from the basic deviation survey of a well. Next we have flow type. We will use tubing flow, and for operating inputs we will use JD and KH, because now we know what the Darcy law for gas is, so we are comfortable with this. So for this demo exercise for JD I will take non-stimulated well and put 0.13. Of course, in your homework, notice that you have different tasks. You have skin of 20 and skin of -3. So you need to recalculate JD based on skin. So for the KH, we'll take this number. Reservoir pressure is here. Temperature is 88. And tubing head pressure will be 2715. This is actual operating parameters of a well. Tubing head temperature is 126. Come on. VGR is 257 and OGR is 932. So now we can go here, click calculate, and it will create a basic model for the West-de-Kearney's 11 well. You can see the red curve is IPR curve, the blue curve is VLP curve, and we have 2 points highlighted, actually 3 points highlighted. First is operating point, when these two curves are crossing. Here we have liquid loading point, and here we have erosional velocity point. Right, so now we created the basic well model, and in this table actually you can see the numbers for the working point and for the absolute open flow. What else you can do here is sensitivity. For the sensitivity you can choose both IPR and VLP parameters. So for your homework probably you will need to use IPR sensitivities on a JD. So here for the highly damaged well, or for a highly damaged well, we can just in the purpose of example I will put 10 times less JD, and for the good well I will put JD of 1, stimulated well. You can click calculate and you will see how it calculates different cases. And of course JD of 1, it creates very good curve. Also we can do VLP parameters, and for VLP usually it's this one. So for example for tubing head pressure we can do a sensitivity on these two, and here you can see what will happen with the well if tubing head pressure will decrease. So now what I am going to do is just save this model to the cloud. I will overwrite this model, and now as it's shared to the public, you can see it right here. So for your homework, what you need is to create the same models for the wells which are listed up there, using wellbore design and well design, using their operating conditions and reservoir parameters, and made some sensitivity and conclude with results. So I think this was a quick demo on the software. Remember, you will need to use PVT and PQplot model. Right now we created 2 models, both of them are available for you. So yeah, go ahead and try. Okay, thank you.